Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2018 Physics Paper 1 Higher Tier, question number 3, which is on the topic of electricity. A student investigated how the resistance of a piece of nichrome wire varies with length. Now, this question is related to the required practical resistance in a wire. Figure 3 shows part of the circuit that the student used. So you have the cell or the battery to be exact, switch and a variable resistor here, and the wire. So this would be the variable resistor there. Let me label that. Resistor. Complete figure 3 by drawing an ammeter and a voltmeter for 3 marks. So the first mark is actually for the ammeter, which should be in series. So you can actually draw the ammeter anywhere along the line except on the wire. So I'm going to draw the ammeter over there, and that should be in series. And a voltmeter, now the voltmeter is used to measure the potential difference along the length of the wire. So you could draw the voltmeter there. Now you can connect that voltmeter anywhere along the length of this wire. Question 3.2. Describe how the student could obtain the data needed for the investigation. Your answer should include a risk assessment for one hazard in the investigation. So what they're asking is, going back to the diagram, how would you use this setup to find how the resistance of a piece of the wire varies with the length? So how would you do it? Let's say you connect this voltmeter at 10 centimeters from there to there at this point. Right? So at 10 centimeters you connect it, you press the switch, that should give you the ammeter and the voltmeter reading. Now the variable resistor is used to make sure that the current in the circuit remains consistent or doesn't change too much. So, and next you would increase the length. You would remove one of the ends of the voltmeter and connect it to at 20 centimeters, and then you would measure the ammeter and the voltmeter reading. Now what you're trying to do is actually for every 10 centimeter increments of the wire, you're trying to measure the different current and voltmeter readings, and you're using the variable resistor to keep the current low as possible or consistent. Now the reason for that is you don't want the wire to actually get hot by allowing a large amount of current to go through. If the wire gets hot, then the resistor actually changes. So you want to keep the wire's temperature as constant as possible. So how do you write all of this? Now eventually, once you get the data, you would record the data in a very simple table. So V and I and R. Now you're going to use this equation V equals IR, and you're going to try to find the resistance by using the potential difference of the volts divided by the current. So you would need different values of voltage and current to get the different resistance. Now in that table you would record the length as well. So 10 centimeters, 20 centimeters, and 30, or you can go up to about a meter. About 70 to 80 centimeters, more than enough as well. So let's have a look at answering the question. Here's a typical answer. Test for a range of wires. Length of wires 10, 20, 30, 40 and 50. Now I mentioned up to 50. You can increase it. At least up to 5 readings is more than enough. Use a ruler to measure the length of the wire. For a given length of wire, measure the current, which is the ammeter reading, and the potential difference across it, which is the voltmeter reading. Take repeat readings for current and potential difference to calculate average values for current and potential difference, PD values. Now, you can take 3 values of the current and potential difference for each length of wire and then take an average. Then you calculate the resistance for each length. Resistance equals potential difference divided by the current, since V equals IR. Plot a graph of resistance against length. Now, the graph would be length there and resistance on the y-axis. The hazard is a high current may cause the wire to melt or to overheat. This may cause burns to the skin, so low current should be used by adjusting the variable resistor or switch off and allow the wire to cool in between the readings. Question 3.3. Why would switching off the circuit between readings may improve the accuracy of the student's investigation? Tick one box. The charge flow through the wire would not change. The potential difference of the battery would not change. The power output of the battery would not change. The temperature of the wire would not change. And that's the answer. 3.4. The student used crocodile clips to make connections to the wire. They could have used a piece of equipment called a jockey. Figure 4 shows a crocodile clip and a jockey in contact with the wire. Now, you can see in the wire, the amount of surface area that is in connection with the crocodile clip, that's quite big. Right? That's at least half a centimeter or less than about a couple of millimeters. Now, a jockey is actually pointed. That point is actually sharp. So when you connect it, you're actually going to just place it on a very specific length on the wire. How would using the jockey affect the accuracy and resolution of the student's results compared to using the crocodile clip? Tick 2 boxes. The accuracy of the student's result would be higher. Yes, that would be correct. The accuracy would be lower. No, the accuracy of it would be the same. No, the resolution of the length measured would be higher. That's correct. Low, the same. No. That brings us to the end of question number 3. I will see you in question number